What is up, CP Finite, and welcome to Chapter 7, getting into probability today. Probability is a lot of what we've already known about probability, and is just the likelihood of an event occurring. Likelihood of an event occurring. Alright, you guys know probability all from weather and from like the probability of it raining outside, sports of a team winning and so forth. The key thing is, there are a few keys here. Probability is always going to be 0 or greater, so probability of events, and it's usually a percentages. Probability is always greater than or equal to 0. But it can't be more than 100. So, but less than or equal to 100. Okay, so you might see it as 100% or just the number 1. Just so you know, there is no such thing. So like when places say, oh, there's a 120% chance of it raining, that's not actually possible. They're just exaggerating. Okay, so basic things today, just some basics of probability. The most important thing with probability is you're always going to need to find the total number of things, and then you're dividing by parts. Okay, so before we even go anywhere with this, we have a table representing the number of people at a Penguins versus Flyers games at the PPG Paints Arena. All right, the total number of Flyers fans is 550. The total number of Penguins fans is 10,000 or 1,050. Let's also total up the number of men, because we'll have some questions with those, and of women. 550 plus 250. It's Friday, I know. I need to do my math here. 800. Okay. And in total, we have 1,600 people in general. These numbers and these numbers should always add to the same thing. All right, now, probability is largely done with random things. So let's just say randomly selected, maybe it's on the prize cam or something like that, probability of the random guess from the sample liked the Penguins. Well, there are 1,050 Penguins fans, and you're going to divide that by the total. So it's the part divided by the total. That's always what it is. The part divided by the total. Part is 10,000 or 1,050 Penguins fans, and the total is 16,000. 1,600. What are you doing, Mr. D? 1050 divided by 1600 equals 0.656, roughly. If you are, so now that we're doing this, if you care to round, that's fine, 0.66. And just remember, if you wanted to write that as a percent, that's just 66%. Okay, so I would like you to write it as a percent if possible, since we are in probability now. Probability that a random male from the sample like the Flyers. Now we're looking at the total number of guys, which is 800. So 800 divided by 1600 is going to just be 50%. So 0.5 or 50. Probability random guess from the sample did not like the Flyers. So did not like the Flyers. That's a complementary event. So if we think of it, here are the Flyers fans, and here are the Penguins fans. It's just another way to word that they liked the Penguins. So there are 1,050 folks that did not like the Flyers over 1600. Again, 66%. Now, what if you're saying, well, what about the people that don't like either team? We're not considering them in this question, but good thoughts. We're just using what the data gives us. And probability of selecting a woman that likes the Flyers. So we're just specific. There are 250 women that like the Flyers. Divided by 1600. 250 divided by 1600 is 0.156 or 0.16, which is 16%. All right, so just remember, it's part over the total. There are different types of events. Overlapping events, they share common events. And disjoint or mutually exclusive, they do not share anything. So they do not share any events. What this means, okay? Probability when you're rolling a six-sided die. Let's just think if you roll a six-sided die, you can get 1, 2, 3, 4, 5, 6. Remember our counting techniques, we would refer to that as our universe. Now let's say the probability of getting an even number. Even number would be 2, 4, or 6, and the probability of that would then be 3 things out of 6 things, or 50%. Probability of a number greater than 2. So the probability of a number greater than 2, let's see here, we have the numbers 2, 3, so we have 3, 4, 5, and 6, which is so 4 out of 6, or in that case, 0.67%, or 67%. Now, notice, okay, even number and number greater than 2, they share an event. They share 4, and they share 6. That's what we mean, or that's what I mean by they are overlapping. So whenever you're determining probability of overlapping events, you don't want to count these twice. Instead, we're just going to add all the individuals. So A or B simply means that we would roll a 2, a 3, a 4, a 5, or a 6. You don't count them twice. So probability of it being even or greater than 2 is 5/6, which is 0.83. So 0.83 or 83%. We'll show you another way mathematically to look at this. Now, let's say you're rolling a six-sided die, okay? And you can just scratch this out. And let's say event A is the probability of you rolling a 1, 2, or 3. All right, that is 3 out of 6, so that is 50%. Probability of B is rolling a 4, 5, or 6. Well, that again is 3 out of 6, which is 50%. They have nothing in common, 1, 2, 3, 4, 5, 6. So they are disjoint or mutually exclusive. In that case, P, A, or B, if we combine the two, we just have 1, 2, 3, 4, 5, 6. Essentially, we're just adding the probabilities, and that gives us 100%. Okay, just for that particular case. So mutually exclusive, nothing in common. Overlapping, do have things in common. Okay, let's look at some examples with a card deck here. We're actually just going to consider a standard 52 card deck. So scratch this out. Okay, for those that don't know, a card deck, there are 13 spades, there are 13 hearts, there are 13 diamonds, and there are 13 clubs. Okay, that's what all those are. You're going to need to become comfortable with a card deck come the end of this. Hearts are red, as are diamonds, and the other are black. Anyway, so the probability of getting a spade from a standard deck of 52 cards, okay, is 13 out of 52, or 1/4, or 25%. Okay. Now the spades. Here are all the spades. 1, 2, or ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or jack, queen, and king. Those are all the spades. Now the probability of getting a 1 or a 2. Well, there's a 1 and 2 of spades. There's a 1 and 2 of hearts, there's a 1 and 2 of diamonds, and there's a 1 and 2 of clubs. Okay, so there are, that should be a club. Okay, there are 2, 4, 6, 8 out of 52 of those. 8 out of 52. is 0.15. 0.15, or about 15%. Now, these are overlapping events. Why? Because, okay, in our spades, we have an ace and a 2. We also have down here in our spades, we have an ace, which is 1, or a 2. So we're actually repeating those twice. So when we take the probability of both of them, we only want to consider writing them once. So all of the cards we could get is the ace and the 2. We can get all the spades. Okay, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. And the other ones we can get are the 1 and 2 of hearts, the 1 and 2 of diamonds, and the 1 and 2 of clubs. So these are the 1 and 2 of clubs. Remember that OR means to add together. So we just combined all those things. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 out of 52 different events, which is 36 or about 37%. Okay? You don't have to necessarily write everything out, but it may help. Now with cards again, probability of a 1 or a 2. We already know that there's 8 of those out of 52, which is 15%. Probability of getting a 3, there are 4 3s out of 52, which is going to be, I'm guessing, 7%, about that. Yeah, 0.06 or 76, or 7.6, you can even say 7.7%. Okay, now these are mutually exclusive, they have nothing in common. So you have the 1 and 2, you have 1 and 2, you have 1 and 2, you have 1 and 2 of each of the different suits. Here you have 3 of the different suits. Okay, in that case, you could just write them all down and add them together. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 52 ways to get both of them, A or B, which we know is 0.23 or 23%. Okay, symbolically, here is what is going on. Okay, if you know that events are overlapping, this is just like our counting principle from before. If they're overlapping, you have to subtract what is shared or what is in common. Okay, it's the two individual probabilities, probability of A plus the probability of B, minus what's in common. And here we always know that probability is equal to 1. Okay, so here, let's say events are overlapping. So I will tell you that they're overlapping. That means that we'll take the probability of A, which is 0.5, plus the probability of B, plus 0.75. Now, if you do that in your head right away, you'll notice you'll get something over 100, 0.75 plus 0.5. At that point, you know 1.25. At that point, you know that it's overlapping because you can't be over 100. Okay? So we're going to subtract something, and that is the probability of A intersect B. What's in common? And we set that equal to 1. So we have 1.25 minus the probability of some intersection equals 1. All right, well, if you just subtract 1.25, subtract 1.25, you get negative 0.25, and we know that's equal to negative the probability And the probability of the overlap then would just be 0.25 or 25%. Okay? Symbolically for mutually exclusive, so you're going to use a different equation depending. Okay, is just you add them both together. There is no overlapping, so you don't need to just subtract it. So probability of A is 0.25 plus probability of B. Hey, that's 0.75. That equals 1. Checks out. 1 equals 1. So that's how you know they're mutually exclusive. It will be tricky, especially if you don't know your card decks. So we will do a lot of practice with that. You can pause here, or if you want to write down what is in a standard card deck, feel free to do that in the space here. I'll do that. So again, there are 13 diamonds. Okay, if you want to know they are red cards, there are 13 hearts. There are 13 spades. And there are 13 clubs. Okay. Face cards are Jack, Queen, and King. Ace, sometimes I will specify if it is or not. Numbers you can think of as ace through 10. And that's about it. So do your best on some of the practice problems. The answers will be up later. So nice job, guys.